everyone, I welcome you all to today's lesson. So this is the question that I gave you yesterday, which some of you answered and some of you found it difficult for you to answer through. So the first question was saying, find the difference between T and R. Have you seen? So you are told to calculate the difference between T is here, and R is where, and R is there. So the first thing that you need to ask yourself is this: are these in the longitude or latitude? This is the first question that should come to your mind. Are these in the longitude or latitude? So T and R is along the what? The latitude. This is the latitude. Have you seen? This is the what? This is the latitude. So if it is in the latitude, you know that the difference is found by using the what? The longitudes. So don't try, whenever you're given something and you're told to find the difference, if they are in the latitude, then you check the latitude. That's why some of you, it was giving you a 0 because your concentration was on the latitude, but you go the opposite way. If they are in the latitude like the way they are, then you check the what? The longitude. This is how we answer these things. Have you seen? So the longitude T is on which longitude? Is on 90. So you say it is what? 90. This is what you are going to do. So 90 degrees west. That is your T. Have you seen? That's T. Then you go to R. R is this one. R is on which longitude? That's the longitude. That is what? It is what? 45 degrees east. Then you are taught to find the difference between these two. Have you seen? So finding the difference, just add different direction you add. So if you add these two, what is the answer? The answer is 135 degrees. So that's what? That's your answer. This is the answer that I expected of you to answer. So this is the answer. Then the other thing, let me just clarify this point. If you find that they are having the same direction, so you know the same direction, you need to do what? You need to subtract. Then you say, for example, let's say you are having 30 degrees south, then you're having 40 degrees south, like this. Then you know that the same direction you need to subtract. So like this, you cannot say 30 minus 40. Definitely you know that you're going to get a negative answer. So we avoid the negative answers. And we are talking about distance. So you cannot find the distance to be in negative. The distance should be what? Positive. So let's make sure we get this point. Have you seen? So avoid that. So this is the answer. So now the other question was, we calculate the what? The distance between what? So we calculate the distance. So the other point was that we calculate the what? We calculate the distance along the what? Calculate the distance PQ. So calculate the distance PQ. This distance PQ. This is the distance PQ along the what? 65 degrees north latitude, on this latitude. So they want you to calculate this distance which is in the latitude. Have you seen? Distance on which latitude? This is the latitude which you are given. So this is the latitude. So the first thing you need to do is to find the difference. This latitude will not help you find the difference, but the difference is found by getting the what? Longitude. So the difference that is between P and Q is the same difference that is between T and R. Why? Because they are on the same longitude. So if you check this one, 90 degrees west, you also check this other one, it is 45 degrees east. Have you seen? So now what you need to get is that if they are on the same longitude, it means that they are having the same what? Same difference, like same longitude, everything is the same. So the answer there was what? The answer between these two was what? Was 135. So how can we calculate this? Then they are on the what? Latitude. The formula for latitude. So I believe some of you are even forgetting how to come up with the formula. So I'm going to give you these formulas. So if you're dealing with the longitude, have you seen longitude? What formula do we use? We say, for example, I'll say AB is equals to theta over 360 times 2 pi r. This is the formula for what? Longitude. I believe you are forgetting. I know some people are making mistakes on how to come up with this. So this is how you need to do. For longitude, as long as it is in the longitude, you are calculating the distance in the longitude. You know the longitude. These are lines that come from north to what? To south. So this is the formula that we use. What about latitude? So what about latitude? So if it is latitude like this, which formula do we get to use? Which formula do we use whenever we are talking about latitude? This is the formula. So latitude, we say AB is equal to theta over 360 times 2 pi r cos, I'll say cos x degrees. Have you seen? So now, since this one is the latitude, the circles in the longitude are the same. That's why we use that radius of the earth. But in this case, that's why we include the radius, the latitude, which is x degrees. Here it is the latitude. Why? Because their circles are different. Have you seen? So latitude are not the same, but the longitudes are the same. So these are the two formulas. Whenever you are calculating distance along the latitude, this is the formula that you need to use. Then the theta here is the difference in the what? Longitudes. Whenever you are calculating distance in the longitude, the theta there is the difference in the latitudes. Have you seen? So this question, the good part is that about this question, these two were asked. And that's where the confusion now came in. And that's why we were not able to answer this question. But I want you to understand this very well. I want you to get the necessary concept so that you never fail any question that will come under earth geometry, definitely in paper 1. Because in paper 2, I gave you topics that you need to concentrate on. So this is just to open your mind to answer a paper 1 question. So this was just to open our mind to answer questions that usually come in paper 1. So now, let us now go to our question. We want to calculate distance PQ. Have you seen? So we want to calculate distance what? Distance PQ. Where is PQ? Where is PQ? PQ is where? PQ is here. This is PQ. So difference here, we already found this one and that one. P is on this. Q is on this longitude. So when you add this to, you get 132. PQ, is it latitude? This is the latitude. Have you seen? They are on the what? On the latitude like this. You are moving from here to there. This is the latitude. Have you seen? So latitude, the formula in the latitude. What is the formula? So you know that when you add this plus that, just the same as you are doing this, you still get the same what? Same answer. So we say PQ, this is what you are going to do. PQ is equal to theta over 360 times 2 pi r cos x degrees. Have you seen? This is the formula that we need to put down. So I say this is now equal to, what is theta? 135. 135 over what? 360 times 2 times, what is your pi? This one. Times, what is your radius? Radius 34, 37. Then you say cos. What is the latitude? They are on which latitude? They are on which latitude? PQ. PQ is on which latitude? PQ. On which latitude? This is the latitude. So on which latitude? 65. So you take, you write your what? Your 65 here like this. Then you say PQ is equal to what? You type everything on your calculator. So we are going to type everything on our calculator. You say 135 divided by 360. you get this is your answer. Have you seen? I've seen that answer. Then I start times 2 times everything that I'm able to see times 3.142 times 3437 cos 65. What answer am I getting? So what answer am I getting? I'm getting 3422.908.172. This is the answer which I'm getting. Have you seen? Then from here you say this is now equal to, I told you that we need to put answers to, so you say not commas. Told you that we need to put answers to 3 significant figures. So 1, 2, 3, like this. You concentrate here. Have you seen? Our main interest, all these numbers after the point are not important. So here now, if you check here, is this number less than 5 or greater than 5? Less than 5. So you can't put a 0 there. So you are going to have 4, then a 2. Then this one will become a 0. We don't concentrate on these numbers which are after the point. Then you say not mouse. So this was the what? The answer. Have you seen? 1, 2, 3. Like this. Is this number less than 5? Yes. If it is greater than 5, you would have put a 1 there. This one would have become a 3. But it is less than 5. We leave it like that, but it becomes a what? A 0, because it is before the point. So that's why we came up with this answer. Have you seen? This is the answer. Then we move to the other question. The other question was telling us to find what? PT. So we use the same diagram. Have you seen? We use the same diagram, PT. So PT. So you want to find what? PT. You check PT. Where is PT? PT. You ask yourself, is it in the latitude or longitude? You are coming from there, going there. So is this latitude or longitude? This is the longitude. Have you seen? This is the what? Longitude. So the language that was used in the question was just to confuse us. But these things are very simple. As longitude. Do you know the formula for longitude? Yes. So if you are calculating the distance in the longitude, the difference is the latitudes. So this one is on which latitude? Have you seen? The difference is the latitudes. Don't forget this. That one, we were calculating this one in the what? Latitudes. The difference was with the what? Longitudes. But now we are calculating in the longitude, this one and that one. The difference is the latitude. Have you seen? So P is on which latitude? 65 north. So 65 degrees north. What about T? T is on what? 55 degrees what? South. Have you seen? This is what we are having. Different what? Different direction. So if you're having different direction, what do? You add. So when you add these two, what are you going to get? You're going to get 120. So you've calculated the theta now. This is the theta that we are going to use. Then the formula for longitude, it is what? The formula for longitude. What is the formula for longitude? We know it. You just see. So it is what? PT is equal to theta over 360 times 2 pi r, like this. Have you seen? This is what we need to do. This is equal to pi there, 120 over 360 times 2 times pi, like this. Then what is your radius? Your radius is 34, 37. Have you seen? 34, 37. So then you type everything on your calculator. So you say 120 divided by 360. You get that answer times 2 times 3.142 times 34, 37. What do you get? What is your answer? 7199.36933. Like this. which is equal to, have you seen, this is now equal to, like this. So 3 significant figures, 1, 2, 3. Your concentration is here now. Is this number greater than 5? Yes. So the moment take a 1 goes there, this one becomes a 0. This one will become a 10. So you cannot write a 10. Have you seen? You cannot write a 10. So this one also becomes a 0. Then a 1 goes there. This one becomes a 2. 7, 2, 0, 0. Then you say nautical miles. These were supposed to be our answers. So you need to know the formula to use whenever you want to calculate the distance in the latitudes and the distance in the longitudes. Let's make sure that we know those two. Then no question will be difficult for us to answer or handle. So these are things that you need to know. These are things that you need to understand. So I want to tell you something. There is a short formula that we get to use in paper 1. Always you'll be told to calculate the distance in the longitude. Have you seen? So the formula that we get to use, let's say this one. Have you seen in the longitude? Let's say this one from PT, like this, PT. P what? PT is equal to what? The formula is theta times 60. This is the formula we use. So whenever you are told to calculate the distance in the longitude, in paper 1, this is the formula that you'll be using. In other words, you just need to know the what? The theta that is there. So the theta was what? When you add these two, this one is on 65, this one is on 55. It was giving us 120. So just say the difference 120 times 60. What is your answer? So you press on your calculator. The same answer that we got, you discover that you are going to have the same answer, 7200 nautical miles. This is the distance. This one is limited. We only use this short formula if we are calculating the distance in the nautical miles. So in nautical miles, this is the formula that we get to use. It's a short way of answering such a question. Have you seen? This is a short way of answering a question. This is how you need to know and understand. So like I've been telling you, these are private videos and they are not supposed to be shared with any person that is not under my teaching. So let's make sure we don't share these videos to any person who is not under my teaching and any person who has not paid the tuition fees. And if you know that your fee is expiring, let's make sure we pay up so that we move together and we see how far we are going to do. So let's make sure we pay up. We make sure that everything is in good terms like this. Let us progress. I said that we are going to look at time now. We are going to look at time like this. So I'm going to do this. Have you seen? This is what I'm going to do. So we've started looking at time now. So in paper 2, they focus so much on time. Paper 1, sorry. Paper 1, they focus so much on time. You'll be told to calculate time. So what I'm going to tell you is that time increases as you are moving to the what? East. So as long as you are moving to the east, time will do what? Increase. So time increases as you are moving to the what? East. This is what you need to get. So which means that the time that is here is ahead of the time that is there. Have you seen? So the time that is there is behind compared to the time that is there. So if here is 12 hours, so here it can be less than 12 hours. So time, you know that this is west. This side is what? East. But the time that is there is the same time that is there because they are on the same what? Same longitude. You need to get this point. Because they are on the same what? Same longitude. This is what you need to know and understand. So since they are on the same longitude, so these are on the same what? Same longitude. So the time that is there and the time that is there, they are the same. But time that is there and time that is there is different. So what do I mean? Time is measured in what? Longitudes. So time here. So if I draw another longitude there and I draw another longitude there, so time that is there is different to the time that is there, is different to the time that is there, different time that is there, different to the time that is there. But the time that is there is the same time that is there because they are on the same what? Same longitude. Have you seen? This is what you need to understand. So 1 degree is equal to 4 minutes. I want you to understand this. 1 degree is equal to 4 minutes. Then 15 degrees, so write this down. 15 degrees is equal to 1 hour. So when I say the time that is here is 15 degrees behind the time that is at that point, which means that the difference is what? 1 hour, because 1 degree is equal to 4 minutes and 15 degrees is equal to 1 hour. So these are points that I want you to understand. These are terms that you need to get. So in an exam, they won't give you this. You need to know this. You need to master it, that 1 degree is equal to 4 minutes and 15 degrees is equal to 1 hour. So let's make sure we get this and understand this point. So let me do this. Let me put a sketch here. Let me do this. Let me do this. Let's say that one, I'm going to give the name of that one. So I'm going to say this one is 15 degrees east. Have you seen? Then I'm going to also name this one. That is, so I'm going to say that is, let me put 60 degrees, what? 60 degrees east, like this. This is what I'm going to do. Okay, not east, let me put west. Let me say there is west there. So west. So if this is A, have you seen this is point A? This is point what? Point B. Have you seen? So that is point A, that is point B. Then you are told that calculate the time that is at B. So you want to calculate the time that is at B. If the time at A, so time at A is 10 hours. Have you seen like this? The time at A is 10 hours. Then you are told to calculate the time that is at B. So how do you do that one? How do you work out that one? How do you work out that one? So I've told you that time increases as you are going to the east side. So which means the time at B is ahead compared to the time that is at B, at A. So B is ahead, then A is behind B. Have you seen? So if here it is 10 hours, which means that here the time there it can be 10, 30, 11 hours, 13, 16, somewhere there. But what we need to know that it should be ahead of time A. So what do we do next? You find the difference in degrees, which is in what? Longitude. So when we are calculating time, we just focus on the what? Longitudes. Don't go to the latitudes. So I repeat, don't get the latitudes. So repetition is for emphasis. I emphasize, don't get the latitudes. Don't get the latitudes. Just concentrate on the what? Longitudes. Concentrate on the what? Longitudes. Don't get the latitudes, please. So I'm emphasizing so that we get the point, because these are simple mistakes that we get to make. So here, even if the time was here and there, as long as they are on different longitudes, have you seen? I get the what? The longitudes. So the time that, as long as some questions, they will tell you that here there is C. Then tell you to calculate the time at C. The time that is at C is the same time that is at P. Why? Because they are on the same what? Same longitude. So time on the same longitude is the same. So calculate the difference here. We calculate the what? The difference between these two. Different, you add. You do what? You add. So let's add. So what are we going to do? 60 plus 50. What do we have? 110. So that's our difference. Have you seen? So the difference is 110 between these two. The difference in degrees is what? 110. So I'm going to do this. 110. That 110, we divide it by what? 15. Because we know that 1 degree is equal to 1 hour. So 110 divided by 15. What do you get? So on your calculator, you are going to get this answer. It will give you what? 7.3333 like this. Have you seen? This is what it is going to give you. So now, you have you seen? You lab this. If you do this, this is a mistake. What you need to do is that you do this. You go on your calculator. You say 110 divide 15. Have you seen? So don't use that division. Use this one here. Over 15. What is your answer? Have you seen? Have you seen the answer? 7. The 7 here is the whole number. Then 1/3. This is what it means. So it is like this. 7, then there is something here. 1, there is something there. 3 like this. So this means that it is what? 7 1/3. Have you seen? This is what it means. So it is what? 7. It is 7, then 1/3. This is what it is. 7. So then you get this thing only here. So these are minutes. This is hours. These are minutes. So you get that one there. Say 1/3 times 60. You want to find the minutes. So this one there, it is 20. So it is what? 20 minutes. Have you seen? So you wrap this 1/3. Nicely, you do this. Okay, I found the answer. So I say it is what time? Then you say 20 minutes like this. Have you seen? So it is what? 7 hours 20 minutes. That's the difference. Maybe you are behind. What did I say? It gave me 7 1/3. You get this one. Multiply it by 60 so that you find the actual minutes, because that over will confuse you. So this is what you get to do. 1/3. After you do 1/3, then the next thing, what do you do? So 1/3, you multiply it. Separate 1/3 times 60. Then here you get 20. Have you seen? So any value, this is what you need to do. Then that answer there are minutes. So which means that the difference in hours, this is the difference. It is what? 7 hours 20 minutes. Since we know that the time here is ahead. Have you seen? We know that the time at B is ahead. So that answer, we know that there it is 10 hours. So since it is ahead, we do what? We add. But if it was here, then we are told to calculate there. The time that we are going to find, we need to subtract, because the time there must be behind. So this one is ahead, so we add. There it is 10 hours. So 10 hours plus this answer that we got. So we say 10 hours. We are dealing with time here. This is 7. So 07, then minutes, it is what? 20 minutes. Have you seen? Then you add like this. So this one, 10 plus 7, it is what? 17 here, 20. 0, you add like this. So the time at B, it is what? 17:20. That's the time at what? Time at B. 17 what? 17:20. This is how you calculate. So I hope we've understood this. We've gotten the concept. This is how we get to calculate time. So I'll give you a simple question that I want you to practice. I see if we've understood. Thank you.